Okay, we'll start with exercises questions. The first one is triad. Okay, this is the average of the first and the third atomic mass. This was given by Doberinier. Okay, I'm just marking those answers directly over here. The second one is octave. Okay, this is properties of the 8th element similar to the first. This was given by Newland. I mark these answers. Then atomic number. This is positive charge in the nucleus. And this was given by Moseley. The fourth one is period. This is sequential change in molecular formulae. I will explain you what this means. Okay, this was given by Mendeleev. The next one is nucleus. This is the sum of protons and neutrons, which is concentrated mass and positive charge, because electrons will have negligible mass. The last one of this is sixth one is electron. This is the lightest and negatively charged particle in all atoms. This was given by Thomson. These are all the answers. I have to explain you a few things from here. Okay. Atomic number, yes, that will be Rutherford. The next part. Now, what is this sequential change in molecular formulae? Okay, this is the part that I have to explain you. That is from the period. Now, I'm just taking the examples of the third period that I'm taking. Sodium, magnesium, aluminium. Okay, this is atomic number 11, 12, and 13. Now, suppose if I'm combining this 3 atoms differently with, say, chlorine, then if I'm supposed to take the formula of sodium with chlorine, sodium, obviously the valency is 1. Chlorine, the valency is also 1. So the formula for sodium chloride will be NaCl. Same way now I am taking magnesium. Magnesium, the configuration, because atomic number is 12, its configuration will be 282, so its valency is 2. Chlorine, chloride, Cl, its valency is 1. If I exchange these valencies 1 over here and 2 over here, the formula becomes MgCl2. I'll take the third part now. Aluminium 283. So its valency is going to be 3. Chloride over here valency is 1. I'll exchange these valencies. I'll bring 1 over here. I'll bring 3 over here. So the formula is AlCl3. So in the same period, you can see as you are going ahead, NaCl, MgCl2, AlCl3. If the next one, if I'm going to take it is going to become SiCl4. So here you see this is sequential changing in molecular formula, that is for the period. So this is for this part that I have considered. The fourth part, the period, this is sequential change in molecular formula. This was given by Mendeleev. You can mark these answers in your textbook. Okay, question number 2. Choose the correct option and rewrite the statement. The number of electrons in the outermost shell of alkali metals is. Okay, number of electrons. Which one? First one, the answer. Alkali metals. Now, yesterday only I have done this with you. Okay, this is the alkali metals. Group 1. So how many electrons will be there in the outermost shell? There will be one electron. Okay. So outermost shell is going to have only one electron. So this is going to be the correct option. The second P question that we are moving on. Alkaline earth metals have valency 2. This means that their position in the modern periodic table is correct. The alkaline metals are these metals, that is group 2. So they will have two electrons in the outermost shell. Okay, valency is 2. It means it is the second group. So this is going to be group 2. The next question. Molecular formula of the chloride of the element X is XCl. Now chloride, as we have done just right now, its valency is 1. It means X is also having valency 1. This compound is solid, having high melting points. This is the property of ionic compound. Which of the elements be present in the same group as X? Okay, so this obviously should have valency 1, so it has to be Na. Si is group 4, so it will be XCl4. SiCl4. Right now we have done the formula. The D part of the question. In which block of the modern periodic table are the non-metals found? Okay, this is the periodic table that is there. The non-metals are in this block which is there. So this block is going to be P block. Question number 4. Write down the electronic configuration of the following elements from the given atomic numbers. Answer the following question with explanation. Okay, the first question, that is A. Lithium atomic number 3, silicon atomic number 4, helium atomic number 2, sodium Na atomic number 11, and P phosphorus atomic number 15. Which of these elements belong to period 3? Okay, so the first thing is we are supposed to write down the electronic configuration of each one of this, and then we have to state that which one of these is going to be in the third period. I want you to take down your notebook, write down all the electronic configurations, and then we will see which element is going to come in period 3. Okay, just take your notebook and start doing it. Only these elements which are given here in the list of these, we are going to write down the electronic configurations. Lithium is 3. What will be the electronic configuration? Correct, 2, 1. You should always look at the atomic number. This is going to be 284. Helium will be 2. Sodium will be 281. And phosphorus will be 285. 285. Now, which of these elements belong to B? Okay, period 3. So period 3, you should look at how many orbits are there. 3 orbits should be there. Na and phosphorus, because you should always look that there are 1, 2, and 3 orbits. If 3 orbits are there, then these elements are going to belong to period 3. So I have marked these elements. These 3 elements will belong to the third period. Okay. We'll move on to the next question. That is B part. Hydrogen, nitrogen, calcium, sulfur, beryllium, argon. Which of these belong to the second group? So again, I will have to write down the electronic configuration of all of these elements. and then I will work out how I am supposed to get the elements from the second group. Okay, we'll write down the electronic configurations of each one of this. I will just take it down. Hydrogen, the configuration will be 1. Nitrogen 2, 5. Calcium will be 8, 2. Sulfur is, beryllium will be 2, 2. And argon will be 2, 8, 8. Now no, 2 electrons are there. It will be completely filled orbit, duplet. It will be only if it is there in the first period. There are 2 orbits. It is in the second period. Look into the periodic table. Okay. The periodic table is here. This is the periodic table. Only if this is going to be the first part, that is first orbit is there, first period is there, then only duplet state is applied. Okay. Otherwise, for all others, it is going to be octet. Second group, it means it should have 2 electrons in the outermost shell. 2 electrons in the outermost shell is this one. 2 electrons in the outermost shell is this one. So calcium and beryllium, this will come in the second group. Valency of beryllium will be 2 only, because 2 electrons are there in the outermost shell. Yes, so valency will be 2 only. Then nitrogen, carbon, oxygen, boron, D is boron, Al is aluminium. Which is the most electronegative element among this? Now we should look for electronegative element. We should look for, there should be 5, 6 or 7 electrons. These are going to be non-metals, and non-metals will be electronegative. So if 7 electrons are there, then it is going to be most electronegative. 6 will be less than that, and 5 will be still less than that. Okay. We will write down the electronic configurations of each one of these. Nitrogen, the configuration is 2, 5. Carbon is 2, 4. Oxygen is 2, 6. Boron is 2, 3. And aluminium is 2, 8, 3. Yes. It will share electrons. It will be forming covalently bonded compounds. Okay. Yeah. Ionic bond will not be there in case of carbon. Now, as I've said, 5, 6, 7 electron, if 5, 6, 7 outermost orbit electrons are there, then they will be non-metals and they will be electronegative. 7 will be most electronegative, 6 will be less than that, and 5 will be less than that. Okay. So you can see over here, the non-metals that are over here nitrogen is there, which is having 5 electrons, and oxygen is there, which is having 6 electrons. So which is going to be the most electronegative element? Correct. It's going to be oxygen, because it is having maximum number of electrons in the outermost shell. So oxygen, that element is going to be more electronegativity. Okay. So that is about the next, this question, that is oxygen is the most electronegative element. We move on to the next question. Beryllium, carbon, oxygen, boron, aluminium. Which is the most electropositive element among these? Now this is the opposite of this question. Electropositive means it must have least number of electrons in the outermost shell. I'll write down the question over here. Beryllium, the configuration is 2, 2. Carbon is 2, 4. Oxygen is 2, 6. Boron is 2, 3. and aluminium is 283. Okay. Now, as we have considered here, lesser the number of electrons in the outermost shell, more electropositive it is going to be. But one more factor also we have to consider over here as we are coming down the group. Okay, this is the periodic table. As we are coming down the group, this way also the electropositivity is going to increase. It is going to become more and more metallic. You can see over here, beryllium over here is in the second period. This is the second period. While aluminium over here is in the third period. So in spite of having more number of electrons, aluminium having more number of electrons than beryllium, aluminium is still more electropositive than beryllium. So this is the answer that you are supposed to keep in mind. Aluminium is going to be more electropositive than beryllium. So we have an odd answer out, going out of the rule. This is, that is, most electropositive element is aluminium. As I have considered over here, beryllium over here is in the second period. Here the electronic configuration of beryllium is 2,2. Aluminium over here, you can see over here, aluminium is here, its electronic configuration is 283. Okay, just before I said that less number of electrons means more electropositive it is. But as you are coming down the group, the metallic character is also increasing, electropositivity will also increase. So beryllium is in the second period, aluminium is in the third period. Okay, so it is down, it is below beryllium in terms of period. It is in the third period and beryllium is in the second period. So therefore, aluminium is more electropositive than elements in the group that are given. Aluminium will be the most electropositive element amongst the group. Okay, NaPCl sodium, phosphorus, chlorine, silicon, magnesium. Which of these has largest atoms? Okay, so sodium is Na. All of them are in the third period. Sodium Na is in the third period. Its configuration is 281. Then magnesium, this is the second element which comes next. Configuration is 282. Then we have silicon Si. From this group we are talking about. Its configuration is 284. Then we have phosphorus, which is 285. And we have chlorine, that is 287. So we have written down the electronic configurations of each one of this from the 5 elements that are given to us. Now the question asked is, which of these is the largest atom? Now we have just done this yesterday only. Across the period, as you are growing, what is happening to the size of the atom? We have just done this yesterday only. What happens to the size of the atom if we go left to right? Okay, as you are going from left to right across the period, the size of the atom decreases. Now the list of the elements that we are provided from here, this is the third period. Okay, sodium is the first element which is going to be the largest atom.